I'm Andy Piper. I'm VP of Engineering at DiffBlue, who you heard mentioned in the keynote. We're a sort of AI provider of automatic testing tools. And I'm here to talk to you about reducing developer toil, autonomous AI for enterprise testing at scale. So here's my agenda. So a little bit kind of philosophical about engineering. I was, actually the keynote touched on a few of these things as well, which I was quite excited to see. So is software engineering getting easier? Is AI helping with that process? What does testing, useful testing, look like? And then the role of agentic AI in solving that problem. And then I'm going to demo at the end. So a little bit about me. I did a PhD at Cambridge, England, not Massachusetts, a long time ago, in MapReduce, long before Google, but other people got the glory, so such is the way things are. I also worked at BEA, for anyone remember BEA? Yeah, a long time ago. So I was on the WebLogic server core team based in San Francisco, working on high availability networking, infrastructure type stuff. And then I moved to real-time data streaming products, WebLogic Event Server, and was part of the acquisition of BEA by Oracle. I got a bit fed up with big company red tape, not getting stuff done. So I switched. I was CTO of a company that was called Push Technology at the time. It's now called Diffusion Data. They've got a real-time data streaming product particularly for kind of e-gaming type data. I then kind of got fed up with living very hand to mouth as CTO of a very small company. Switched back to big company, CBRE, the biggest real estate company in the world, and really decided I did not like big companies and red tape and not being so here I am back at DiffBlue. We're an organisation about 45 people based out of Oxford, UK, Oxford University spin out. And that's me. And my hobby on the side is not drones per se, but writing flight or software. Right? So that's kind of my side hustle, if you will. All right. So modern engineering. Is software engineering getting easier? Show of hands. Anyone think software engineering is getting easier? Okay. I was hoping it would be that sort of balance, but yeah. So I wanted to kind of look at this from a couple of different perspectives. One is sort of the wider context around development. So, and this was kind of mentioned earlier. So one of the things that's going on at the moment is people are expecting from the same people, right? Anyone having massive increases in headcount for their organization? No, didn't think so. No, certainly not true of mine. My boss is in the back. So. Yeah, so generally more is being expected of the same group of people. Or the same is being expected from a smaller group of people, which I'm sure resonates with people as well. Generally, headcount is usually the biggest cost to any sort of organisation, particularly large organisations. If you can cut those costs, potentially you can cut overall costs. So more is expected from a lower set of resource. And set against that sort of delivery context, security constraints are getting wider and broader, and everybody expects security. So our products, when we try and sell into any large organization, it's an absolute nightmare. Security checks and balances, go through the checklists you had to, all that sort of stuff. So, and it's a given, it's not going away. No one's going to say, oh, don't do security anymore. This is just what's going to happen and what's going to continue. And also the validation of what's going on is increasing. And particularly people use do this with tools. So again, mentioned in the keynote, the tools are great at finding issues. Of course, what you do with those issues is another question. But what good looks like is quite well known now. So particularly things like DORA, everybody familiar with the DORA metrics? Come across those? So they're typically used as a good proxy for engineering velocity, and it's based on good data that shows organizations that adhere sort of in a positive way to these metrics generally have better outcomes, better velocity. And so we know what good looks like, and we can use tools to enforce that good. So tool-based checks and balances increasing. And just a reminder that cost is, as I've mentioned, is at the forefront of these constraints. And some of the things that people used to do about cost may be not so great, such great ideas anymore. I had a good friend who was VP of engineering at one of the cloud-based systems. Most of their engineering was done in until relatively recently. And so, it's those sorts of offshoring does reduce costs, but there are risks associated with it. And I think people are becoming more aware of those risks and looking for other ways of doing it. That's kind of the wider context. So what about developers? So here's my contentious statement. Developers' innate intelligence is the same as 50 years ago. Anybody think this is not true? Okay, you think we're more intelligent?
I think there's the Flynn effect, in which IQ has been increasing about 3% every decade.
Okay.
More recently, it has actually dropped.
Okay. So maybe a little bit more intelligent, but no, okay. But not orders of magnitude. So at least not what I'm aware. And education is a little bit of a mixed bag. I don't know whether it's your experience. I interview a lot of people. I see a lot of CVs. There's a lot of CVs where people claim certain things about what they know, and the reality tends to be fairly skin deep. I mean, obviously there are exceptions to that rule, but I wouldn't say that our education system is necessarily pumping out much better developers. They know different things, but the bits and bytes that perhaps our sort of fathers learned you about, but it's not like this sort of that full scale leap forward. But we do know what good looks like, as I keep saying. So the bar for good is getting higher. So when we have very efficient teams, we can ascertain how they did that, and we sort of know what those characteristics look like. And everybody kind of assumes that they're good, assumes that they can be good, but the reality is a little bit different. And so we use tools to enforce that best practice. And you're familiar with a lot of these, I'm sure, like things like SonarQube for sort of coverage, code smells, that sort of stuff. PyTest, mutation testing, various security tools that can be used. Again, these are sort of tools to enforce the best practice bar. Okay, so kind of to the theme of my topic, well, where does the toil come from? So this is kind of my thesis. So we're expecting more, but the amount of checks and balances that we have are increasing. And essentially that is what a lot of developer toil is about. We just talked about tech debt. That's a key element of developer toil is kind of make work. It's not getting productive stuff done. It's just kind of developing to stand still, as it were, so to make forward progress. So manually addressing these things is, I would say, is impossible. Certainly some of these security checks and balances, manually addressing these things is very, very difficult, and it's only possible in the age of tooling that we have, but still hard. So AI. So we kind of, AI has been reported to be the sort of grand savior to this type of problem. So is it helping? Who thinks it's helping? Not many people think it's helping. Who thinks it's a wash? So who thinks it's making things worse? Okay, right. So it's everybody hedging their bets. So I think it is helping, but it's also not. In some way, I'm hedging my bets as well. Okay, so the use of AI. So we all know this. AI can dramatically increase raw output. You only have to say, write me a security policy for a large organization, and it'll spew out 15 pages of quite reasonable stuff based on other documents. So it's very easy to produce large amounts of raw output using GenAI in particular. But it can also be output that's not quite right, and not quite right is usually not good enough for most organizations. It has to be perfect, otherwise, why would you do it? So I kind of call this red tape failure, but I'm open to other suggestions, but that's sort of my word for the day. So the output is, we talked about this bar that's increasing. Often the output of GenAI is below that bar, and being below the bar is not enough for most. So take co-pilots as an example. So I talked about Dora earlier. One of the things about one of the metrics that Dora measures is rework. So rework is a cost for your organization. And lack of rework is considered a good velocity metric. So anyone here used Copilot, never had to rework what Copilot did? No, didn't think so. That doesn't mean that Copilot isn't useful, but that rework is a cost, and it's a well-known cost, and it's worth bearing in mind those sorts of costs when you're considering the use of AI and GenAI in particular. So verification of what AI is doing is really essential, right? You can't just kind of fire and forget. You've got to know that the thing you're getting is true, is trustworthy. And I've got another talk which is all about trust. And can you trust AI? Maybe, I don't know. But with all these things, better not to make a mistake in the first place. A lot of the sort of manufacturing techniques came out of Japan. It's all about not making mistakes, doing things right first time, not kind of doing things at 80% and then going back and moving around and fixing things. GenAI really isn't very good at that. It would be my thesis. Produces good output, large amounts of good output, but it's not perfect, and sometimes perfect is what. Okay, so where does testing fit in this? Well, testing is a kind of verification. I said you've got to verify the output, but testing is the way that you verify output, and software verification. But who's going to verify that verification? Who's going to test the testers, as it were? Well, typically it's a human. You're using GenAI, there's a human in the loop, and they're the one doing the verification of the verifications at work. And it kind of works quite well, particularly for sort of creative processes. But as soon as you get AI sort of marking its own homework, you get into all sorts of problems. I mean, very truly example, hallucinations are kind of an example of sort of marking your own homework. If you feed AI inputs into AI, you tend to get worse and worse results. So generally you need something else in that loop to make sure that the output you're getting is correct. Testing in particular needs to be trusted to be useful. So again, this sort of aspect of trust. It is important to be able to trust the test that you wrote. You don't want to keep asking questions, well, is the test right? You want to be focused on the real problem, which is your code. Is your code right? So what does useful testing look like? I'm sure this is all very familiar to people. Obviously, it needs to be correct. You need to have tests that actually do what they say they're going to do. They need to have high coverage. So it's possible to have perfect tests that test very little of your code. Again, not very useful. So you need to catch the bugs. You can. I think one of these sort of classic examples is you can write very high coverage tests that catch absolutely nothing. So it's that combination of coverage with assertions that produces useful tests. Oops. Yeah. So it needs to catch the bugs. It needs to be understandable. So testing is sort of part of the development flow, part of the development output. It needs to be maintainable in a way that developers can change tests if they need to know, if they need to understand what the testing is doing, so that if the test breaks, they can kind of know how to change their code. It's not sufficient just to have generated code and no one knows what's going on. It needs to run quickly and cheaply. I've certainly come across organizations where getting stuff to production takes months, simply because of QA. Just takes months to get through. So the faster, the cheaper that the testing can be, the better for sort of high velocity outcomes. And it also needs to understand what your code does. So one of the things about GenAI is it often works on what it sees, which often can be comments that might be wrong. And so good testing needs to actually be based on what the code actually does, not kind of some semblance of what it does. So that's useful testing. What does useful AI testing look like? So if we add AI to that mixture, well, clearly it needs to generate useful tests. So all of the above. But also, my thesis is that it needs to be useful. It needs to do that without intervention or human verification, because otherwise you sort of it's just back to creating work for yourself. And if you put those two together, then you can produce Toil. The combination of generating useful tests without yet the rework, the human intervention aspect. So the good news is it can be done. Well, I wouldn't be standing here talking about DiffBlue if it couldn't be done. Certainly that's our experience. But interactive code assistants tend to not be the answer. So they're good for the creative flow, good for creative processes where you want, hints, tips, you want a starting point, you want something you're going to verify, but for testing, not so great. Because that takes too much focus away from the real problem, which is productive work. You want to actually be focused on developing code, not the problem, which is kind of the testing element. And that sort of non-productive work is an opportunity cost. So especially at scale, you're sort of taking away things that the developer could be doing by making them focus on other things. So where does agentic AI fit in this? So agentic AI is all about using AI autonomously, also goal-directed self-improving. I mean, there's a whole sort of pyramid of agentic AI features, but I think the autonomous aspect is one of the most important. And here's sort of the way I contrast assistants versus agents. So assistants, they're good at the 80%. Good at assisting with tasks, and where that 80% has some value to the organization. Obviously, there's some context where that 80% is not that valuable, but quite often, particularly in the creative process of code writing, that 80% can have value. Whereas agents, if they can work autonomously, should be 100% correct, trusted to be 100% correct. So this is all about sort of producing more at higher velocity. So as I kind of keep emphasizing, assistants are good for that creative code writing process. And that's because when they have errors, and they will have errors, they can be reviewed. And so if it's sort of integrated in that code writing process, you're still producing output that is useful to you, still can increase your velocity because there's a human in that loop. Making sure that the end result is actually correct. Whereas agents need to be error-free. Because if they're not error-free, if you start having to dive in there and check the stuff yourself, it all gets a bit painful. It's a bit like, talking about PRs coming from people you don't know about. That, how do you know those things are error-free? Well, you don't, right? So that's good. So for agents to be useful, they need to be trustable, be error-free. And LLMs are not very good at writing error-free code. They're ill-suited to these agent workflows because of this lack of precision, because of this lack of trust. And obviously people are wrapping new things around LLMs. There's sort of a degree of interactivity that is increasing the output, and they're getting better and better, but they're still not error-free. And sometimes that matters, particularly in testing. Now, there are other ways of solving this problem. We use reinforcement learning, and reinforcement learning is actually quite a good way of producing autonomous outcomes that can be trusted. I won't sort of get into the details of how, but I've got a couple of slides sort of setting the general scheme of certainly how DiffBlue works in this context, but it's not LLM-based. So just sort of a little bit of the sales pitch. So I do have a demo later. So we have an agentic AI solution, reinforcement learning based, and it operates autonomously to write Java unit tests based on the Java code. And the great thing is it's self-verifying. So no human has to get in there and check whether the thing is actually correct or not. It checks that itself. And because it's trusted, because it's operating autonomously, it can operate at scale, which again is a very important part of these sorts of problems. Often assistants do not scale. Right? As soon as you have to get a human involved in that sort of feedback process, your scaling is gone at that point. So this is kind of in my sort of very kind of VP of engineering layman's terms, how we work. Our CTO said, well, it's kind of wrong and right, but close enough. So hopefully this makes sense to people. So everybody familiar with fuzzing, test fuzzing? So basically test fuzzing, you fire random inputs in a program and see what breaks. So you take your program, take your inputs, you run the program, and you find an issue, and then you go around the loop again, permutate inputs, usually randomly, and it's quite a good way of discovering bugs that otherwise would not through manually writing tests. So that's fuzzing, well known, been around for a long time. So the AI is, sorry, maybe break it down. There we go. Okay. All right. So you can couple test generation with fuzzing. So instead of just saying see what breaks, you can write a test off the back of seeing what breaks, relatively straightforwardly, and go around this loop. Now, there is a problem with this, of course. If AI fuzzing relies on going around this loop very, very quickly, generating lots and lots of permutations, if you just did this naively, like this fuzz test generation, you would end up with hundreds of thousands of tests that were not particularly useful. But it can be done. You can use fuzzing to generate tests. So then what you want to do is start to introduce AI into the mix. And so the first thing you want to do is you want to make sure that you get unique tests for unique types of data. So if we generate a test, let's see whether the test is different to the previous test that we got. And if it is, then we'll keep the test. If it's not, we'll go around, try again, try some more data. So that's the sort of context for what we do. And this is what we do. So it's that sort of loop, but instead of just looking at differences between tests, we're using reinforcement learning to enforce a goal that we're after. In particular, we're after good coverage. So we have a loop here where we are trying to generate tests that increase coverage, but also increase coverage with the fewest amount of tests. We can use other metrics, but coverage is the main one. The other thing we're trying to do is figure out what we do next. So one of the nice things about fuzzing is you can iterate very quickly through lots of random sets of inputs, almost completely. Sort of get to the end of your random sets of inputs and job done. In this context, there's far too much that you could possibly do. And so one of the things about reinforcement learning is you're taking this sort of probabilistic search through the space of things that you could trying to build up a set of, we've got sort of a tree of scenarios here. So a scenario might be, this looks like a Spring project versus this looks like a Quarkus project or something like that. You're trying to sort of narrow the problem space so that you can try different types of test writing to see what kind of tests you get. Because your goal is to generate tests that generate output in the smallest possible time. Now, the other thing here is it's also not just about data. So if it was easy as just finding the right sort of data inputs, then this process would get a lot easier. But a lot of the time, you've got to sort of build up the entire context. So people talk about, obviously, simple unit tests are testing POJOs, so very easy to test POJOs. But often, to write a proper unit test, you're having to set up some kind of context where it's the interaction between different types of objects. And that context is really important. And if you don't know about that context, you're not able to execute around that context, then you can't get a test. So we look for sort of contextual prompts in what we're seeing, particularly in the code base. We're looking at the bytecode to look for sort of values that we might try, but also we're looking at kind of domain knowledge that we might know about. So in the financial services domain, we might know about particular kind of, take a simple example. If something says, if something is expecting a credit card number, we will provide data that looks like a credit card number, not something that looks like someone's name, for instance. So there's sort of context there that is not just about data, but it's also about the context within which the data is in. And just sort of wanted to re-emphasize this is about a probabilistic search in space. So that trying everything is never an option. You're always compute bound, you're always time bound. And so you've sort of got, and this is sort of how reinforcement learning works, you're using a goal to drive your search so that you can reach some sort of conclusion in a reasonable time frame. Can't brute force it. It's probabilistic, and we're searching the outcome. All right, so this is what DiffBlue does: goal-oriented, fully autonomous AI agents, and we autonomously write unit tests by searching for them, and typically 50 to 250 times faster than a human might. And this is not a DiffBlue conference, this is a Modern conference. So this is part of a wider landscape. So why is this important? Obviously, testing is important to us, but testing is software verification. And software verification is important when things are changing, in particular, doing things like refactoring. So if you're going to do refactoring, you need to verify that before and after is correct. And this is where the sort of combination of these two sorts of ideas becomes quite powerful. And software didn't change, you wouldn't have to verify it. You just kind of left it alone, because no one leaves it alone because upgrades, all the rest of it. But if you could leave it alone, you wouldn't have to do any of this. But software is always changing, either through development or upgrades or some sort of modernization process. And if it starts to change, then you've got to verify it. And without testing, those sorts of changes become extremely risky. Like, how do you know that the change you made is correct? And we see this with some of our customers, particularly with sort of large legacy code bases, not many tests. People are paranoid about changing those sorts of things. They just don't know whether they've broken anything. All right, so this is kind of work in progress, but we do have a combination of Modern and DiffBlue. And the idea here is kind of as I articulated. So Modern provides these recipes for doing upgrades of particular types of code, but in particular, if you're trying to upgrade versions, for instance, what you might want to do first is verify that you have good test coverage for the upgrade that you're going to do. If you don't have good test coverage, what are you going to do about it? Well, that's where we can come in. So DiffBlue can write tests for the code that you can upgrade. You can then do the upgrade using Modern. And then afterwards, you can verify the upgrade using the existing tests to make sure that the upgrade produced code that is still correct and it's still working. So a simple idea, but as I say, sort of work in progress. I think we're announcing this today. Is that right?
Again?
We're announcing this today.
Yeah, it's on the wire this morning.
On the wire this morning. All right, so live demo, maybe 2 live demos, we'll see. So first, I'm just going to show DiffBlue, and just so you can get a sort of feel for what DiffBlue looks like. So this is Spring Pet Clinic. Everybody familiar with Spring Pet Clinic? You're a Spring person. So if you're not familiar with Spring Pet Clinic, so it's a demo application produced by the Spring guys that just demonstrate lots of features of Spring. We use it as our sort of demo application. And it's got a bunch of tests associated with it. But I think one of the things, so I'm going to be looking at this method, process find form. And I think a couple of things to notice about this. So this is a controller, a Spring controller. There is lots of context that is required to set up a unit test for this. So it's not sufficient to just call the Java method. You need to kind of know that actually this is going to be a HTTP request, that the data in the HTTP request is relevant, et cetera, et cetera, et cetera. So just writing sort of bog standard Java for this will not produce a test that any developer would say, yes, that looks like a good test. And some of this context is provided by annotations. So any tool that is going to write tests, and these annotations do something, so they provide context for their execution. Any tool that is going to write tests for something like this needs to understand what the annotations look like. So I'm just going to start DiffBlue running on this particular method. And while that's running, I just sort of want to, we're sort of getting down into the weeds here, but just to show that sort of process find form, it's got a number of different paths here. And what we want to do is we want to generate a test for all of these to get complete coverage on the method. So we've got one here where owner results is empty. We've got one here where the results has only one element, and then we've got the sort of default path here where you've got more than one element, and then there's a kind of error condition where the last name isn't present. All right, so it's written tests for this method, and having talked about code assistance not being the answer, our IntelliJ plugin is geared up into an assistant type mechanism because that's what developers want when they're in the IDE. But it's important to point out that DiffBlue is also a scaling CLI solution. So it's something you can integrate into CI. You can run the CLI across an entire code base, generate tests for all your code in one go. This is just a way for me to show you what's sort of going on under the hood. So I'm going to look at the tests I've got, and I'm just going to accept all of them because I trust it. Okay, so I've got some tests here, any controller tests, and what I'm going to do first is run those tests and just demonstrate that I got full tests that compile and pass. Also, I could do it for the owner as well. So if I dig into the tests that were actually created. So here we go, owner controller DiffBlue test. So I think first thing to point out is the context is all understood. So it knows how to use the Spring testing framework to write tests. It knows how to auto wire elements into the test. So it's using the Spring native mechanism for writing those tests. It's writing tests that are somewhat understandable. So the test is giving it's telling us what the test is trying to do, providing some comments, providing a name. And then what you'll see is we actually got 4 tests. If you remember, there were sort of 4 different paths through through the owner controller. So we've got one here, which is, is adding 2 owners. So this is the sort of default path. And another important element to understand about this is these are still unit tests. So it's writing the correct mocks for the elements that are not part of the method under test. And this is, a key element of writing good unit tests is they should just be testing the thing under test, but then set up the correct context around that, and mocking is usually the way that you do that. We've got that test. Okay, so then we've got this one, which is the single owner test, if you remember. And then we've got one that is model size 1. That's the other. I'm just looking for the null one. So maybe this is the null one. It looks like null. Not sure which one is which there, because those are both null. But the point is that you basically got complete coverage for a single method, but you can scale that up. Scale it up across the entire code base. I could run the CLI on the whole of that. So the other demo that I've got is just to show you that, not that one. Just to show you that the modern stuff is not just vaporware. Okay, so this is the modern DiffBlue integration, and I think I find, find my license key. And then start running the modern DiffBlue integration. So this is still sort of work in progress, some leaving things to work out. But the basic point is that you can use a modern recipe to kick off the DiffBlue test writing operation. I think some of these repositories work, some of them don't. But yeah, you sort of get the idea. That's interesting. They all got green ticks, so Sam must have been working on it last night. It didn't work yesterday when I tried it. All right, back to this. Okay, so DiffBlue cover can be your trusted agent because it's precise. The tests always compile and pass. It can scale. So I didn't demonstrate the CLI as part of this, but the CLI can be used to run across an entire code base. It's continuous, so we have lots of people integrated this into CI, so they generate tests as part of their development process. It's much cheaper than just hiring a bunch of engineers to do equivalent work. And it is agentic as well, fire and forget. So hopefully you sort of gleaned something useful from that. So AI agents and assistants both have their place, both are useful. But testing agents can be used to accelerate development. And we in particular use reinforcement learning to do this in a trusted, quick and accurate way. And if you want, you can try DiffBlue. So those are we've got sort of downloads for plugging in CLI, but we also have GitLab and GitHub versions. All right, any questions?
So I just learned what fuzzing was. I hadn't heard that before. And I know you said that with DiffBlue, that's kind of coupled up with your AI that you're using. I was wondering kind of how you mitigate junk tests being created.
So there's a couple of different. So the question was, how do you mitigate junk testing process? A couple of different answers to that question. So the first is that all of the tests are validated. So we basically discard any tests that don't compile, run, and pass. So at a base level, none of the tests you get will be junk in the sense that they don't work. Sometimes it's not possible to write tests for certain particular types of code. So, complex code paths can be quite hard to get into that. So we will also provide sort of pro forma tests for that sort of code where we can generate a complete test, but we've got a sort of starting point. You can choose whether you're going to set that up or not. Do you ever get tests that are junk? I mean, a lot of our engineering effort is spent on exactly solving that problem, because basically developers are a hard bunch to please. So you saw the naming. So our tests used to be named, test process find form 1, 2, 3, 4. Everybody hated that. No one could get past the fact that there was an integer on the name of the test, even though they were the same test. So people wanted. So it's that sort of thing that developers get really rotated on. So we spend a lot of time making sure that the tests we generate are not junk in any sense of the word. They're tests that developers will say, yeah, that's the sort of thing I would do. That sort of answer your question.
Yeah, that was my main thought at first, was like, if you're getting a ton of these tests generated, like you were talking about before, you can have a ton of tests written, but they might not be really testing what you want to test. Like it might not be actually covering anything you're testing exactly what you want to make sure. So that was my first.
So there's also another part to that question, which is at the moment we generate tests simply based on code execution. What we want to do, and what we're sort of close to completing, is to take the existing tests, which might have been written by the developer, into account in the context, so that we will only write tests that sort of complement the existing tests.
Oh, cool.
So that's one part. What we might want to do in the future is actually take all of those developer tests, take that coverage, take that starting point, and then regenerate everything. Trust DiffBlue more than trust the developers. So
I was going to ask that too. If you develop something that can refactor already existing.
Right. So at the moment, no, but it's something we're looking at. And actually, one of the things we did, so when we first got into this, it was very much about test generation. And actually maintenance is a big part of testing, like fixing existing tests run. Now, at the moment, our solution is we'll regenerate tests for you. And then obviously that works because we're producing tests on the past. What you really want is to be able to kind of make the small modifications to an existing test that takes it into a new test. So that's something that would.
Along the same line as junk tests, so I'm thinking of two different kinds. One are duplicate tests, and the other are tests that are written to ensure that written as the code currently is, not what it's supposed to be. So can you address both of those?
Yeah, okay. So first one was duplicate tests. So we don't write duplicate tests because the goal is coverage. And so we won't write tests that basically duplicate coverage. So we wouldn't. So duplicate tests will not.
Even across the context of
even across the context. So what we're trying, coverage is one goal, but we're also trying to minimize the number of tests as well. So if you have like 10 different tests for a particular piece of code, we will pick the best for some value of best that gets maximum coverage for the smallest number of tests. And you get into all sorts of subjective things here as well, like what people consider a good test versus a bad test. There's the whole not writing trivial tests things, like some people, constructors, destructors, setters, getters. Some people like I don't want tests for those. Others are like, well, that's clearly part of my coverage that I need. I do want tests. And there's like some of these things don't have a right answer. It depends on the developer you're talking to. Your second question was
testing what it's supposed to.
Right. Okay. So yes. So
I have a follow-up with the coverage.
okay. So we can't determine intent. That's a given. So we can only test what the code actually does.
Mm-hmm.
That's still useful because that's what regression testing does. But we can't determine intent. So if the developer, I mean, the classic example is, I don't know if you tried this with Copilot, ChatGPT or something. You write a comment that says something completely different to what the code actually does, and you ask it to write a test. You'll generally get a test for the comment, not for the code in Copilot. Now, is that measuring it? Is that testing intent? I don't know. It depends on whether the comment is right. But generally, we take the view that what the code does is the most important thing, and that's the most important testing. If we could kind of reach into people's minds, we would, but not at the moment. You had a follow-up question.
Yeah, for coverage, so what kind of coverage do you need? Like up to like MCDC coverage, or
I'm not familiar.
I forget what it stands for, but essentially, if you have a complex condition in a statement, let's say there are 5 variables involved, 5 Boolean variables. So there are 32 combinations. MCDC minimizes that. Okay. But still, it's
so we're certainly taking branches into consideration. We're sort of based off branch coverage, line coverage. We're also trying to look at boundary conditions for values. So and which is sort of part of the coverage. So all of those things considered. I couldn't give you an exact, explicit example of yes, we do this, and this, but certainly we're trying to consider all of those things essentially to generate tests. I would say that's the kind of thing.
Yes.
Yeah. I know historically you focused on Java-based code bases. You've partnership with the German Green Vision, using their LSPs on other programs to expand for reading Python, Java. They're using their Java-based access to these other language LSPs.
I don't know. I mean, certainly we're looking at other languages all the time. It's a fairly large investment for us to tackle another language. I don't think we're not leveraging the modern LSTs into it at the moment, but it's a technology landscape that's changing all the time. So I think we could easily see doing that.
How do you decide on what kind of SW technique to apply, like starting by mocking?
Yeah, good question. Because some of this stuff is subjective. Like what a developer will say is the right way of doing it. Typically, we use mocking where we can, and one of the big challenges with mocking is deciding how much to mock, because it's not very. And so we have various heuristics we apply that try and generate the smallest number of mocks for the method and test. We also allow the user to make some decisions about what kind of mocking they want to see. So, like simple things like mock this method, don't mock this method. It's possible to mock everything, come up with this text that is completely not understandable. So some of that stuff we have to put in the hands of the user.
And what kind of tests? So there are different forms of theory testing. It depends on how people define it. You can say you test more on the method level, test more on combinating different classes together. So you do user unit testing, but yes,
we're mainly focused on the method level.
Yeah, that's also a good question. You mentioned that there's room for a developer to choose, influence how much mocking happens. In the demo you gave, could we have, for example, instructed DiffBlue not use mocking at all and construct a real owner repository instance based on an in-memory database? That's about it.
Yes and no. So you can certainly turn off more. We have explicit support for some Spring features that do what say you do, because often doesn't make very much sense to most. They're supported explicitly. It's not like a user switch or whatever.
They'll say those are like deterministic support, not based on having an LLM produce an implementation of how to wire in a Spring repository for this.
So I can
Because they'll say like for every explicit Spring feature, you have integration with that because you have written code to instruct DiffBlue how to what patterns to use to interact with the Spring feature versus exporting that to an LLM and asking it how do I wire up the Spring feature for this test.
Yeah. So if the first one is true today, so a lot of the Spring integrations are based on our understanding of Spring and test features. We are currently in the process of leveraging LLMs more to build out some of these patterns that essentially, particularly in the case of domain specific data and domain specific rules.
And I have a second question. So in terms of DiffBlue and reinforcement learning, you see like a broader SDLC path where DiffBlue can be aware of a code base's changes over time and specifically track false positive test failures from DiffBlue generated tests for scenarios where the developer indicates the application is still working as expected after making changes.
I mean, certainly we have a reporting product that captures DiffBlue data over time, and so you can look at the contribution of DiffBlue versus unit tests and how that changes over time. We don't have an explicit kind of when DiffBlue did it wrong, but it's certainly something that makes sense.
Oh, is that just a feature of it?
Yeah, it's called cover reports, but it comes with products.
So to touch on the junk tests again, it's like, is there a way right now to review what the junk tests are, or are they just?
Yeah. So you saw when I said it's accept all in the IDE there.
Oh, I see. That's
so you can say review it. You can review each test.
Okay.
And if you said, I want to get template tests as well as actual tests, you'll be able to review those and say, yeah, I want that versus no, I don't.
Just because sometimes, like, it's more like almost like a test-driven approach where it's like the junk tests could be actually illuminating something.
Yeah, exactly.
Yeah,
exactly.
Okay. Right.
Yeah.
And then kind of like a follow-on to that is like, do you see, touched on a little bit, like more of a test-driven approach where you're working with maybe user-generated like spec that was used to generate the code to then inform that intent piece?
Yeah, so
I know it's not,
No, I mean, TDD in particular is a good question. So I think, so kind of our take on TDD is, lots of people say they do TDD, but don't. Do a little bit of TDD. And I think there's a sort of, there's a good path for us there, which is in particular writing tests from tests. So with TDD, typically what you'll do is you'll write your kind of steel thread test or whatever, and you'll write your code off the back of that. When you got to go and fill in all the blanks, no one has the time or the inclination for that.
Exactly.
But we could do that, right?
Yes.
Based consuming that existing test. We then got a good starting point to fill in everything else. So that's certainly one of the outcomes we see of this particular piece of work that's going.
Where do you see DiffBlue fitting into the development workflow? Because I can definitely see like, okay, I have code that doesn't have a lot of tests, go and generate 1,000 tests. What if I have a feature branch and I'm adding new methods? Like, where does DiffBlue fit into that? Does it run like after the branch is created and add tests for you, or how do people use DiffBlue when they're writing new code branches?
Yeah, so you can certainly, well, it sort of depends on how you set it up, but certainly we have customers who, as part of CI, DiffBlue will run on the branch, GitHub or whatever, and generate tests for you off the back of that. You could obviously generate the test manually as part of your PR. But I think one of the key things about what you're talking about is, again, you want to make sure that you're taking the existing context into consideration when you're writing new tests, so you're only getting the tests for the new features and not for everything. So one of the features we do currently support is called sort of patch mode, where if you've got a PR, we'll look at the bits of code that touches, and then that will be used as sort of an input to the tool to only write tests for that area of the code. Any other questions?
So where exactly the tool is installed?
Oh, good question. Great question. All on-prem. So no cloud-based service. Your code never leaves the building. It runs on normal sort of hardware, although there is some compute required. So trying to run it on a 2D laptop probably not going to work that well, but typical sort of CI machines. Yeah, it's all on-prem. One of the reasons for that is we have integrating into the build system is pretty important part of it, because we have to be able to run the tests, have to be able to run the code. So trying to ship that all off to a cloud-based service, we tried that in the past, didn't work very well. But also, no one wants their IP to leave the building.
Then how it will integrate with the modern software as a service, cloud solution?
Well, so the way we currently do that, so you saw there was a GitHub and GitLab integration. So that's a SaaS-based version where essentially DiffBlue has been integrated into their cloud-based CI pipelines. But you've got to get the test generation and the code execution and building in the same place for that to work. So you either have to get your code off into the cloud somewhere, or the other way around.
You talk about SonarQube. How do you kind of ensure that something that DiffBlue would be generating playback will not do follow the standards guidelines? Because with AI used today a little bit, say ready to testing. Of course, that kind of what those gates are, and then so how do you kind of play it?
Yeah. So the first is that we respond to all of the complaints from our customers who complain a lot about that sort of thing. Like SonarQube, cleanliness is really important to them. So we make sure that the tests that we're writing conform to sort of basic standards of cleanliness. But we're also doing things like trying to integrate with the build system. For instance, formatting. We make sure that we use the native formatter that's in the project for tests and that sort of thing. So we do it. Obviously, it slightly depends on what the customer is, turned on explicitly in their environment. But it's certainly no one wants hundreds of thousands of warnings from SonarQube from generating tests.
I can say I fully understood how it all works, right? This may not even be everybody else, but do you parse the code, the source code, and present, you try to analyze it somehow, basically a representation of the path that it executes, and then try to, on the back of that, to create test input to validate it?
Yeah. So we used not to parse the code. We used to work directly off the bytecode, so that would give us the methods to test. It would allow us to execute the code. We have got into parsing the code a bit more because there's certain things like comments, for instance, that people want to preserve that are only in source code. But yeah, parsing the code in some way is our kind of starting point for writing tests. But then we're also going to execute code as well as part of that test writing project.
Yeah, so I guess if you were just doing brute force and generating randomly, you waste people. So by understanding some of the branching of some value collecting, we can get efficient generating values that are do something meaningful and exercising that. And there's no GenAI involved.
No.
And is that deterministic? You always get the same.
It is because no one. The last thing you want is to run DiffBlue, get a test, run DiffBlue again, get a different test, and then you've just got sort of red and green ink all over your PR. So the tool generally generate same tests for the same inputs if you run it multiple times. There are some caveats to that in the sense that it is a probabilistic search, and you can change the parameters of the search. So if you search for a much longer time, you might get some extra tests. So there is some caveats there, but generally it's
And is it tied to any like specific frameworks? I work for a large part with like thousands of applications for the past 20, 50 years or something. EJB applications, things like that, not really surrounding them. These are the ones that are interesting because we like modernize and do something about them, but we don't have much testing around. So would you like different Java frameworks?
It works across the vast majority of well-used, well-known frameworks. Some of the tests have to be framework specific, and so we have to sort of build in that support. But we had to sort of talk to you and get into the details. But I mean, the ones you just mentioned do have support.
Right. Like I have some EJB application with like 20 years ago. Is your knowledge recognized EJB taxonomy or like they're like interfaces or like a simple way of writing
Right.
EJB, session beans, enterprise, entity beans, and things like that. You'll need to understand how it works so that you can figure it out.
It generally needs to understand how the framework works because there are specific ways of testing specific things. But so, for instance, take messaging, for example. You have, if you want to test messaging, you do it in a particular way. You can't just kind of write tests for the methods you see. That said, we will always generate tests for Java code. It's just they might not be that useful because it doesn't take the context into account.
And one question, when you're generating this code itself, that's not using GenAI. You somehow determine to generate.
Probably ought to wrap it up there before the next thing starts. Good. All right. Thanks very much for your time.